All right, we're taking notes. Grace, will you go back to your desk so we can get some notes? All right. So these notes are on the indefinite integral. Before we get into that, I'm going to give you a little bit of context, okay? So at the beginning of the school year, we said the limit as h goes to 0 of f of x plus h minus f of x over h was what? What did we say that was? This is the derivative, right? Okay. No, not enough information. That's the derivative. And this is not a derivative in saying, oh, that's the instantaneous rate of change at a specific point. This is the derivative as an equation. It's the equation of a derivative. So that I have some sort of equation, and then for any point on that equation, I can say, okay, that's the instantaneous rate of change at that exact point, okay? So we have this is kind of general. Then we have the one that was the limit as x approaches a of f of x minus f of a over x minus a. And this was also the derivative, but let's be more specific about it. It's the derivative at a point. So we looked at the derivative in two contexts. We said the derivative is the slope at a specific point, and we had some answers where we would do the derivative, it would give us a specific number, and we do that was the number of the slope. But we also had the power to find the derivative written as an equation, and then we could use that equation to find any different slope at any different point that we wanted. All right, we're going to do the same thing with integrals / antiderivatives. Okay, so hopefully today we're going to have kind of a big picture understanding of what we've done. So we already learned how to do from a to b f of x dx. And what does this notation give us? Area under a curve. Area under a curve on a specific interval. You would be able to, we'll get to that eventually. You can get an answer if it's something that is bounded, but not something that just like goes on forever. Yeah. Would they still assign that to 0? Yeah, basically. Yeah, they'd all cancel out. All right, so this is called a definite integral. It's definite because it's defined as an interval from a to b. Today we're learning about indefinite integrals, which would just say the integral of f of x dx. And what this is going to give you is it's going to give you the equation to calculate the area under the curve. So not for a specific interval, it's going to give you an equation that you could use for any interval you wanted, okay? It is the supreme power. All right. Now that we have that, let's go ahead and write it again. So we're going to say f of x dx equals capital F of x plus c. So when I ask you to take the integral, of something, what is your answer giving you? What is this called? What is it called? Antiderivative. So when you take the integral of a function, the antiderivative is the answer. So now we've learned a new inverse operation, kind of. Derivatives and antiderivatives are opposites of each other. Derivatives and integrals are opposites of each other. An integral will undo a derivative. A derivative will undo an integral. Does that make sense? They are opposites of each other. Okay? So f of x plus c, where f of x is the antiderivative. when you take the derivative of something, what happens to the exponent? It drops by 1. When we take the antiderivative of something, what happens to the exponent? It increases by 1, which is why it makes sense that we're getting areas. We're getting something squared. Does that make sense? Oh. And that's because we've got that length and width, right? We're multiplying a length times a width. We're getting a dimension squared. So that's why you're finding the area under a curve. Yes? Yes?
Are integrals the inverse of any derivative, like whether it's anti or derivative?
An antiderivative is another word for an integral. An integral gives you an antiderivative.
If you use an integral in the second derivative, or maybe the first derivative?
Yes.
Well,
It'll give you the derivative within a plus c, within a constant.
And then if you get the function, you'll get within a c plus c.
Mm-hmm.
That's weird.
Mm-hmm. Yeah, there's a process. All right, so here's our first example. We're going to say, take the definite integral of x to the third plus 5 sine x dx. And let's make sure to not forget that dx because we don't want to kill the little piggy. Now that we officially have it on the wall. Yeah. Yes, and if you forget the plus c, you kill a baby hedgehog. Go look at the picture because it's a very small hedgehog. It's very cute. All right, so what's the little shortcut? What do we do for x to the third? So I add 1 and divide by that number. All right, plus 5. And then the antiderivative of sine is negative cos. Okay, so if we clean this up.
Yeah, because if you, so when you bring it down.
There's nothing in front.
Yeah.
But if there's 4 in front. I cannot understand a single word you guys
So if you think about how derivatives work, we would have had a number in front. We would have multiplied that. 4 times 1/4 is what made the one up here. So to undo that multiplication, we should be dividing. So if there were a number in the front, you would divide by it. So if derivatives involve multiplication, then antiderivatives should involve division. Yeah. So 1/4 x to the 4th minus 5 cos x plus c. There's our antiderivative. Now, before we go much further, I want to remind you guys of something I showed you, because it can help. I have found that when I do my sine and cosine derivatives, they like really mess with my mind. So sine x, why am I putting it on the y? Sine corresponds to the y. Cos x, negative sine x, negative cos x. Okay, so when we take derivatives, we go this way. Derivative of sine is cos, derivative of cos is negative sine, derivative of negative sine is negative cos, derivative of negative cos is positive sine. When we take antiderivatives, we go backwards. Okay, so antiderivatives, the antiderivative of sine is negative cos, the antiderivative of negative cos is negative sine, antiderivative of negative sine is positive cos, antiderivative of cos is sine. So if that helps you, if you're a visual person and that helps you, just remember like the normal way you read a clock, right, clockwise is derivatives, backwards would be antiderivatives. Okay, that can be helpful. I know because the rules are so similar that sometimes it's hard to remember which one's which. All right, next example. We're going to integrate 4 square root t minus secant t tan t dt. So 4 square root t minus secant t tan t dt.
Replace all the t's with x's.
Nope. Can I replace the t in your name with an x and just call you Zobi from now on?
You can end up doing a math problem as long as when you get to the answer you change it back to
No. All right. So we have, I'm going to go ahead and rewrite this. I'm going to say that this is 4t to the 1/2. What is the benefit of me doing that? Yeah, it's easier to work with. Okay. So what do I need to do? So I take the exponent, I add 1. So I've got 4t to the 1/2. I'm adding 1 to that. And then I'm dividing by 3/2. Okay? And then I have to think about what trig function had a derivative of secant tan. Secant. It's just secant.
It's easier if you have secant x, tan x.
It gets your brain better. So what do I do with this to like make that look nicer? So 8/3 t to the 3/2. I mean, it's a little bit nicer. Okay. Yep, got the plus c so we don't kill a hedgehog.
When you have, would you prefer we do t with t or less here?
So I would say, it doesn't really matter as long as you can go back and forth for a multiple choice. F or Q would take both. There.
Would it take to the 3/2?
Yeah, with FRQs, you don't have to simplify equations. You don't have to simplify numbers. So if you had 50 over 100, they would take that. You don't have to say 1/2. And then anytime you could say square root of x squared, they would take that. You don't have to simplify it. Yeah. You can, as long as that number doesn't really need to be used again. So if it's like evaluate something and like plug it in and it's clear that that's like the final answer, then you just plug the numbers in, you call it good. And just don't simplify. Yeah. All right, one more example. You guys are not going to like this one because it's going to mess with your brain. It's not difficult, but it's going to mess with your brain a little bit. So the integral of 6 theta squared minus 7 secant squared theta d theta. No, you cannot change the variable. So what do we do? Okay, so this is negative 7 tan theta. I don't ever do that in my head because it messes with my brain too much. I gotta see it. Yeah. So we've got 6 divided by 3 is 2. 2 theta cubed minus 7 tan theta plus c. Done.
It becomes a lot easier if you just ignore all the weird variables.
Just, yeah, think about it. That's it. No. Well, the theta messes with a lot of people.
You just have to ignore it.
Yeah. I knew you guys wouldn't like the variable choice. So for your assignment, we have 7 through 28. No. 35, 36, 39, 40. All right, so backside of your worksheet. These are the problems you're doing. Yeah, but these don't take very long. Yeah.
Oh, yeah.
All right. Let me show you. This is an example of rewriting. Putting it to the 1/2 instead. Integrate, simplify. So rewrite, integrate, simplify for the ones that are making you do the chart. They're just having you like show all your steps. basically. Okay. Any other questions? Yes.
Alex, you're legally old enough to adopt me, so don't call me old. Wait.